Are we alone in this universe? It's a question that has haunted mankind for decades. And now a new spacecraft is on its way to find the answer. It's called the Europa Clipper.
Europa is already known for its eerie landscape of long fractures, chaotic terrain, and hints of a vast salty ocean. But could it be hiding something even darker? Is humanity truly prepared for what the Europa Clipper could potentially discover? NASA's Europa Clipper mission is set to embark on one of the most exciting and mysterious space explorations in history. This spacecraft has journeyed to Europa, one of Jupiter's moons, to study its icy surface and hidden ocean. Join us as we dive into the mystery and explore NASA's warning. Europa Clipper's findings could be disturbing. The hidden ocean quest. The quest for life beyond Earth has captivated humanity for decades, and one of the most promising destinations for this search lies on Jupiter's moon Europa. Once a relatively obscure celestial body, Europa burst into the scientific spotlight after hints of a hidden ocean were detected beneath its icy shell. This theory, which once belonged to the realms of science fiction, now stands as one of the most exciting possibilities in modern astrobiology. And it may soon be a reality thanks to ongoing space missions. Back in 1972, scientists at the Kitt Peak National Observatory in Arizona observed that Europa's surface was composed mostly of water ice. This discovery, along with thermal models from 1971 suggesting the moon's interior could contain a liquid layer, ignited early interest. However, it was NASA's Voyager missions in 1979 that first brought Europa into vivid focus. The images Voyager 1 and Voyager 2 sent back were revealing, showing a smooth, bright surface crisscrossed with dark bands and few impact craters. These findings hinted at a young, active surface, possibly renewed by icy volcanic flows or shifts in the ice layer itself, striking evidence of dynamic processes below the surface. This unexpected lack of craters suggested that Europa's icy shell wasn't as static as it appeared. Scientists noted matching patterns on either side of these cracks, resembling pieces of a jigsaw puzzle. It was as if the surface had been pulled apart, allowing darker material from below to flow up and fill the gaps. The Voyagers didn't pass close enough to provide concrete proof of what lay beneath, but the clues suggested an active, perhaps even warm, interior. The next step in Europa's investigation came with NASA's Galileo spacecraft. Launched in 1989 and arriving at Jupiter in 1995, Galileo's observations took the mystery to new depths. One of its most significant findings was a disruption in Jupiter's magnetic field around Europa, hinting at a conductive layer beneath the moon's icy crust. The most likely culprit? A salty global ocean lying below Europa's frozen surface. Estimates suggest that Europa's ice shell may be 10 to 15 miles thick, floating on an ocean possibly 40 to 100 miles deep. This means that despite its small size, Europa's hidden ocean could dwarf Earth's in volume. Given these conditions, scientists see Europa as one of the most promising locations in the solar system for finding life beyond Earth. The icy surface might conceal a deep ocean environment that could be chemically similar to Earth's, which, under the right conditions, could support microbial life or even more complex organisms. In recent years, technology has given scientists thrilling glimpses of what lies beneath Europa's icy shell. The Hubble Space Telescope detected what appeared to be plumes of water vapor erupting from Europa's surface, reaching heights of up to 100 miles. And in 2019, NASA confirmed water vapor above Europa, measured using the powerful spectrograph at Hawaii's Keck Observatory. These plumes may be a sign of volcanic or hydrothermal activity on the ocean floor, potentially providing the energy sources needed to support life. If confirmed, these plumes could allow scientists to analyze Europa's ocean indirectly. A spacecraft could fly through a plume, collecting samples without drilling through the ice. This technique has already proven successful at Saturn's moon Enceladus, where the Cassini spacecraft detected organic compounds in its icy plumes. For Europa, this method could unlock secrets about the ocean's composition and possibly signs of microbial life. Even if no plumes are found during future missions, Europa's icy surface may still offer access to its hidden ocean. Studies suggest that tidal forces from Jupiter cause the ice shell to stretch and flex, pushing warmer ice from below to the surface. This process could carry samples from the ocean's depths, freezing them into the crust where a spacecraft might analyze them remotely. Europa Clipper, unlocking secrets. With Europa's potential as a cradle for extraterrestrial life, mission planning ramped up. Following Galileo's groundbreaking discoveries, NASA developed several mission concepts, eventually leading to the Europa Clipper mission. The Clipper, launched in 2024, is designed to orbit Jupiter and perform numerous close flybys of Europa. This approach avoids the intense radiation near Europa that would harm a spacecraft in direct orbit. Instead, the Clipper will fly past Europa as frequently as every 2 weeks, mapping the surface, measuring the ice shell's thickness, and studying the Moon's atmosphere and magnetic field for signs of water. Equipped with a powerful suite of 9 science instruments, Europa Clipper is designed to collect an unprecedented amount of data on each flyby. Instead of directly searching for life, the mission's scientists are tackling the foundational questions needed to support such a possibility. The spacecraft will measure the thickness of Europa's icy shell, analyze how the ocean beneath interacts with the surface, and determine if essential ingredients for life are present. Each instrument, from visible light and infrared cameras to advanced spectrometers, will capture details from Europa's surface and beyond, creating a multi-layered view that combines imagery, temperature readings, and chemical composition. This collaboration is crucial. Europa Clipper's cameras will map the Moon's surface in finer detail than any previous mission, capturing features that hint at geological activity, like crustal shifts or possible water plumes venting into space. The infrared cameras will analyze the Moon's temperature and surface composition, unveiling details about its chemistry and the processes shaping its environment. The Europa Clipper will work alongside the European Space Agency's Jupiter Icy Moons Explorer JUICE, launched in 2023. While JUICE's primary target is Ganymede, it will make a few critical flybys of Europa, providing complementary data. These 2 missions, with their advanced scientific instruments, will investigate Europa's ice, search for plumes, and probe the magnetic environment, bringing us closer to answering the question, could Europa's ocean support life? For life as we know it, 3 conditions are essential: water, the right chemical ingredients, and a reliable energy source. With evidence of all 3, Europa's frozen landscape might be hiding more than just water. Europa's ocean has likely existed for billions of years, long enough for life to have emerged. Astrobiologists who study the conditions for life across the universe are particularly intrigued by the possibility that Europa's icy crust conceals vast, salty seas. These oceans likely contain carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, elements found in all known life forms. This cocktail of ingredients suggests that beneath Europa's ice, life may have had the right conditions to develop over time. Energy, however, is the trickier part. On Earth, sunlight powers photosynthesis, driving life up and down the food chain. But in the dark depths of Europa's ocean, sunlight doesn't penetrate. Instead, life on Europa would likely depend on chemical energy, derived from reactions between minerals and water. This kind of energy is abundant around hydrothermal vents on Earth, where life flourishes without a glimmer of sunlight. If similar chemical reactions happen on Europa, they could provide energy for any microbial life there. Interestingly, the powerful radiation from Jupiter's magnetic field could actually aid the process. Although deadly to surface life, Jupiter's radiation might interact with Europa's ice, producing chemical compounds that sink into the ocean, providing fuel for life below. Finding life on Europa would have profound implications. If life independently formed there, it would suggest that life is a natural consequence of the right conditions, a notion that could mean the universe teems with life. Astrobiologists are eager to explore Europa further, with planned missions hoping to drill into its ice or analyze particles expelled from its ocean. Each data point brings us closer to understanding whether we're truly alone or part of a much larger cosmic family. Europa's size, about 90% of our moon, makes it an inviting target for exploration. If it replaced our moon, it would shine even brighter in our night sky, with its icy surface reflecting over 5 times the sunlight at about 417,000 miles from Jupiter and roughly 500 million miles from the Sun. Sunlight reaches Europa much fainter than it does Earth. But the allure of Europa's hidden ocean lies in its potential for life. Europa's dynamic surface. NASA's Galileo spacecraft revolutionized our understanding of Europa during its exploration of the Jovian system from 1995 to 2003. Through a series of flybys, Galileo uncovered that Europa's surface isn't just frozen and static. It's shaped by dynamic forces beneath the ice. One of the most striking findings was evidence of convection in the Moon's icy shell, where warmer, less dense ice rises while cooler, denser ice sinks. This process, powered by heat from below, suggested the possibility of a hidden, active ocean beneath Europa's frozen crust. Europa's surface tells a fascinating tale of geological forces at work. Long linear fractures, typically a mile wide but extending for thousands of kilometers, crisscross the moon. Some fractures have formed massive ridges hundreds of meters tall, while others have spread into bands of parallel cracks. In areas called chaos terrains, the surface seems to have collapsed, creating broken, blocky landscapes covered in mysterious reddish material. Scientists suspect that these regions could be where subsurface lakes are pushing through the ice, possibly releasing minerals like Himalayan salt crystals or halite. These salt formations could offer clues about the moon's chemistry and the processes occurring beneath the surface. In 2013, using the Hubble Space Telescope, scientists found evidence that Europa might be actively venting water vapor into space. This finding suggested that Europa could still be geologically active, with ongoing processes beneath the surface. By 2019, this theory was confirmed when an international research team detected water vapor directly above Europa's surface, fueling hopes of studying Europa's ocean. If these plumes are indeed linked to an underground ocean, future missions could fly through them and sample the water, offering a rare glimpse into the moon's hidden depths without drilling through the thick ice. Adding to the excitement, Galileo's measurements of Europa's magnetic field revealed a peculiar disruption. This anomaly pointed to an electrically conductive fluid deep below the surface, likely a salty global ocean. The presence of this ocean, rich in minerals like Himalayan salt crystals and halite, is still the strongest evidence we have for an ocean beneath Europa's icy shell. This discovery makes Europa one of the most intriguing places in the solar system, holding potential for life and valuable insights into the chemistry of alien oceans.